Welcome back. Today is the lecture 5 of Financial Mathematics for Actuaries. What we are going to do today is we will synthesize the concepts that we have studied in week 1 and we will try to solve some basic problems based on those concepts. So here what is a game plan is given on the next slide. So what we will do today is basically we will synthesize all week 1 concepts. We will master the equation of value, which typically gives us the time value of money, and we will practice some BA2 plus keystrokes or keystrokes using scientific calculator. So the protocol that you need to follow in this particular lecture is you first see the problem, then you pause the video, try to solve the problem on your own, and then resume the video and attempt the solution, okay, by using the walkthrough that I am giving you. So we will strictly follow this protocol. I will give you a space of 2 to 3 minutes, that is the typical time in which you are expected to solve the problem and synthesize the concept. Okay, so let's begin with our first mission, doubling time analysis, right? This we have already used in previous lecture, and now it's just a revision of what we are expect, right? So basically the question is, I have $100 and I want to find out when they will double. Okay, I have been given an interest rate of 8%. So you have to find the exact time n, then you have to use the rule of 72 to verify your result and get back to the solution. Okay, so pause this video now. Now we are coming back after 3 minutes and let us analyze what we are trying to do. So I have something like $100 at my disposal. I have invested it, so I will have an interest rate which will be 1 plus I. I have this raised to n function, and what will be the value of that? Will be 200, correct? So if I look at this expression and I divide throughout by 100, it will become 1 plus I raised to n is equal to 2. Now I have to solve this equation. The hurdle is n is in the exponent. I have to get it in the linear scale. So the only solution that we have is take the natural log. So taking natural log on both sides, what I get is ln of 1 plus I raised to n is equal to ln of 2. Okay, so that typically comes as, if I have ln of x raised to a, okay, if I have this kind of thing, then I will write a times ln of x. This is the formula in logarithms that we use. So I use this formula and I convert this into n times ln of 1 plus I, which is equal to ln of 2. And now I know this I. What is this I? I is given to be 8%, so 0.08. So I will use this I to be 8% and I get n times ln of 1 plus I, so 1.08 is equal to ln of 2. Okay, that simply means if I want to get the real estimate of n, I need to take ln of 2 upon ln of 1.08. How will you do that? There are two ways. One is you can use approximation, another one is you can use calculator. So let us use calculator. A general scientific calculator will also work. For example, a calculator like this. We have already shown you the keystrokes in the last class. So again revise this. So what I will do is, first I will press the key 2, then I will take ln of that, which the output is displayed on your calculator. Then you are dividing by this number, so divided by, what is a number? 1.08. So use this 1.08, and then I have to take natural log, so the scientific shortcut is here, and then I have the division. So you can see here it's ln of 2 divided by ln of 1.08. That's what I want to estimate. Press equal to sign. You get the answer to be approximately equal to 9.006. You can verify once again. 9.006. I have chopped it, so it's roughly 9 years. Okay, so now printed display of whatever methods that I have done here. Okay, so step 1 is you are setting up the equation. You are equating 1.08 is equal raised to n is equal to 2. Then you are bringing in the natural logarithm, and you get this n times ln of 2. This is the second step, and then final step is on the calculator, where this is in this sequence you have displayed the output. 2 ln gives 0.6931 divided by 1.08 ln gives you 0.7696. Pressing equal to sign gives you 9.006 years. Again, this is not over. You have to verify this answer, right? So you have to use the rule of 72. What is the rule of 72? Whatever is the interest rate I, in my case it was 8%. Okay, so now I will multiply this interest rate by 100 into I, 100 into I. So that will, this is 8 by 100 into 100, so this will become 8. I will divide number 72 by this number, which is 8. So I get 8 9s are 72, so 9, right? So 9 years is the approximate answer, and my answer is very close to that number. Okay, now I have repeated the question. What if my interest rate is 10%? What will happen, right? So we will do the same question by taking the interest rate to be 10% and show you how close the answer is. So for that, what we will do, we will again use, if the interest rate is 10%, 100 becoming 200, it's just step 1 is 1 plus I raised to n is equal to 200. Step 1 still remains the same. I have not actually substituted anything there. So if I go back and do all the steps, let me do it once again for you. It's 1 plus I raised to n is equal to 2. Then this was our step 2, step 1. Step 2 was, you just take n times ln of 1 plus I. So this I actually is equal to 0.10. So 1.1 is 1 n times 1 plus 1.1 times ln of 2. So I have jumped 2 steps now, and therefore my n is equal to ln of 2 upon ln of 1.1. Whatever is the answer, we can calculate it from our calculator. So let's go to back to our calculator. So the process is essentially the same. I will demonstrate the process again. I will press 2, then as mentioned here, I will take 2, then I will press the ln sign, so that ln thing is pressed now. So I got ln of 2, then I will press the divided by sign, divided by, then I will take 1.1 in this case, so it's 1.1, and then take ln of that, which will give me some answer. So I have the equation, which is ln of 2 divided by ln of 1.1. That is what this equation is. Okay, and now I will press the equal to sign. I get the answer to be equal to 7.272. So I will trim it at second decimal, 7.27. Now is our, so it basically it takes 7.27 years if the interest rate is 10%. If the interest rate is 8%, it takes 9 years. If the interest rate is 10%, it takes 7.27 years. Now this answer is not done yet. So we need to check whether I have made any calculation error or not. For that, what is a verification rule? Rule of 72. So I is equal to 0.10. I will multiply this I by 100. So 100 times I is 0.10 multiplied by 100. So 10 by 100 multiplied by 100. It will take away this. So 100i will be equal to 10, and you divide 72 by 10, roughly you got 7.2 years. Yes, so I am fairly close to this. But as you can see here, in this case it was 9.006 years, and therefore 9 years was fairly good estimate. Here it's 7.2, but 7.27. So this is slightly going forward. So this rule of 72 works well between 4% to 12% regime. If you go beyond that regime, this rule may not work well. So always remember this, but most of the questions that will come in the exam will be in this range only. So most of the time this rule will work. Okay. So your rule of 72 is verified for two different problems. Now let's jump to the next problem, which is the equivalence trap. You have been told that a fund earns 5% simple interest. Okay. I want to find the equivalent compound rate I that I should offer over a period of 5 so that this particular thing is achieved. Think about it, pause this video, try to attempt the solution, and once you have attempted, resume this video. I will show you the answer. So now we will try to attempt. So first of all, a fund is earning 5% simple interest, and now you are asked to compute the period of 5 years. First of all, I should know how much the fund will earn in 5% at 5% simple interest in 5 years. So how will I do that? So we have already done this calculation where we saw this whenever it's a simple interest, it will be T times I, that's the interest that it will earn. Okay. T times I, that's the interest it will earn. And what is T? T is the time. So in this case T is equal to 5 and interest rate is 5%. So I is equal to 0.05. So that's the interest that it will earn. So what will be the accumulated value of this fund? Okay. So that accumulated value of this fund will be 1 plus T times the interest that it has earned. Okay. Assume that whatever is the initial value, let's say that value is P. So whether it matters, it doesn't matter actually. Let us see. So accumulated value will be given by 1 plus 0.05, which is my interest rate, into 5 multiplied by P, which is the principal. So it will be 1.25 times the principal. The principal is immaterial. For considering the accumulation function, we will consider the principal to be 1 unit. So if you put P to be equal to 1, so a 1 unit will actually have the accumulated value of 1.25. Correct? So this is my understanding. Now I want to see how in 5 years, if I use this compound interest rate model, how will I get this 1.5 as an answer, right? So there are how many years? 5 years. So what I need to do now is, for this accumulated value, how will I get, what interest rate I should put so that I will get the answer to be equal to 1.5. We will start with initial capital of 1, and if I use my compound interest rate model, I will have something like 1 plus I will say I compound raised to n is equal to 1.25. Do I know this n? The answer is yes. I know this n, and this n is actually 5. Okay, so I have this equation now. Now this is the equation that I need to solve. So let us take this equation, and this equation essentially means I need to compute 1 plus IC equal raised to 5 equal to 1.25. So I need to take the 1/5 power of that, so that 1 plus IC is equal to 1.25 raised to 1 by 5. Okay, and if I am able to compute this, I have computed what will be my interest rate. Let us see if I can do it using the scientific calculator that we have shown earlier. So this is my scientific calculator. Let me bring it here. Let us clear the function. Okay, so what I need is, I need 1.25. I will use the functionality x raised to y raised to 1 by 5 is actually 10 by 50, it's 0.2. Okay, so I will say raised to 0.2. Okay, that will give me a number which is 1.04563. So I will chop it 1.04564. So this number is equal to 1.04564. Okay, so now you take away this 1 from both sides, then what you get is this IC which is the compounding interest, to be equal to 0.04564. Okay, so that means what is the interest rate that is required? It's 4.56. If you want to ignore this 4, you can ignore 564%. That's the interest rate that we are looking for. Okay, so that answers this question. Let us see a printed solution of this. So your first accumulated value, okay, not the amount function, it's the accumulated value. So we will start with 1 unit, and your accumulated value will be 1 plus TI. So that's the 0.05 into 5, which will give me 1.25. That's okay. So that step 1 is very clear. Then we have to match with compounding. So we will say 1 plus I raised to 5. This is our compounding model, equal to 1.5. So as I did in the handwritten thing, you will take raised to the power 1 by 5 on both sides, and you got 1.25 raised to 1 by 5. You have seen how to compute 1.25 raised to 1 by 5 using the calculator, and now you know what will be the answer. It will be 4.56. That's the easiest way. Because I explained, I took slightly longer time, but as such this calculation is just a 2-step calculation, so you can easily do it in 2 minutes. So here one checkpoint or the conceptual note that we need to verify is, simple interest is increases at slow rate, compound interest increases at faster rate, and therefore the time it takes for simple interest rate to grow to a certain level should be larger than the compound interest rate. In this case, we are essentially looking for the interest rate, and then if you are talking about the interest rate required for compound interest to reach a certain level will be smaller than the interest rate required for the simple interest to reach. That's the conceptual note that I am talking about, where why should I be less than 5%? Because when we are compounding, our interest itself earns interest. When we are in the simple interest world, our interest is useless, it's not earning on interest. Okay, so we can afford to have lower rate in order to achieve the same result if you are in the compounding world. That's the key takeaway from this particular problem. Okay, so I have solved the second problem. Let us move on to the third problem. This will be slightly tricky, but yeah, you can understand. So this is the first time we are handling multiple cash flows, where money is coming to you at different time points, and when money comes to you at different time points, we call them as cash flows. So what is happening here? At time 0 you started with $1000. At time 1 you received another $500. At time 2 you received another $500. Now you are asked a question at time t equal to 3, if your accumulated wealth, okay, at time t equal to 3, what is the value of your accumulated wealth if the interest rate given is 6%? I repeat the question once again. There are three cash flows in this. At time point 0, you started with $1000 in your account. At time point 1, you received a payment of $500. At time point 2, you received a payment of $500. Wherever you are keeping this money, the interest is given at the rate of 6%. You are interested in finding the accumulated value at time point t equal to 3. Pause this video, attempt to solve this problem, and once you have attempted and verified your answer, please resume the video. We will walk through the solution. Welcome back. I hope you have attempted the solution, and now let us walk through the solution. So first of all, from the beginning I have been saying that money has time dimension. So you cannot compare the cash flows at different time points. We have to bring them to the same level. So let us see, if we bring our cash flows to time t equal to 3. So this 1000 rupees invested at time point 1, we will call this as flow 1. Okay, flow 1. This is 1000 rupees invested. These 1000 rupees must have earned the interest on 3 time periods, where for each time period the interest rate is 6%. Therefore, I will use the model 1.06 raised to 3. We can calculate this value. Similarly, if I look at the flow 2, this flow 2 actually came at time point 1. So time point 2 is the first time step, time point 3 is the second time step. So this 500 that have come must have accumulated the interest for 2 periods. Okay. And the flow 3 which has come, this will be 500 into 1.06, must have accumulated the interest only for one time period. Okay. So now we are talking about all this money at time point 3, where we can add this point. So the money dimension is shrink to time point 3 now. There is no time dimension to money now. Okay. So what I will do, first I will calculate these numbers. So again we will take help of our calculator to calculate these numbers. So it's basically, I will clear everything that is given there. So it's 1.06, and then I will choose x raised to y. I want to have 3, which will give me some answer, which is 1.191. I will multiply this answer with 1000. So that's my first answer, 1191.016. 1191.016. Okay, so this is my first answer. Let us do a similar thing with this particular answer. So again I will clear it. 1.06 x raised to y. Here I can actually do square x square, but it's okay. 1.26, and I will multiply this number with a number 500. Okay, so that gives me 561.8. Okay, let us do this final bit. So this is 500 into 1.06. 530. So now what I need to do, if I want to compute the accumulated value of this, I need to sum over all of them. So let us do that summing with calculator, where I have 530 plus 561.8. Here I can optimally use the memory function also. 1191.016, which will give me 2282.816. 2282.816. So this is one way to figure out the answer. Is this the fastest way? Depends. Okay. So now this particular focus, or this particular way of calculating and bringing the money to a certain time date, that particular time or date is called focal date. So in this case, the t is equal to 3 is focal date. So we have done this. Move the $1000 at time 0 to level 3. So it's 1000 into 1.06 raised to 3, 500 into 1.06 square, 500 into 1.06 raised to 1. So we have done all these things. Then we need to simply add those things, right? And we got 2282.82. So what was our answer? So it's rounding off. So 6 is rounded off to 2 decimal places, because generally money is rounded off to 2 decimal places, right? So that's how we got the value, accumulated value. Here with BA2 plus calculator, you can minimize your time, or you can work more efficiently. Here is a demo of that. You choose these keys: cash flow, CF, second, clear work. Then in CF0 you enter 1000, in C01 you enter 500 and then enter, then F01 you enter 2, and then you press the NPV, then you enter I is equal to 6, press the enter key, CPT, PV at t equal to 0 will be given, because this particular set of operations will give you move all the cash flow to time point 0, and then you multiply your answer with 1.06 raised to 3, which will give you the accumulated value. So now I hope the calculation is clear to you. Okay. So today whatever we have done so far, we can summarize it in this. First, you take the exact value for that money problem or the number of years problem using logs, okay, and the logs give you precise answer. Rules of 72 is for estimation, which is for verification purposes. Then equivalence of simple interest and compound interest, we have matched simple interest and compound interest. The compound interest will be lower whenever the time period is greater than 1. We have also analyzed a common trap with t between 0 and 1, where simple interest exceeds the compound interest. Whenever you are given a question of cash flows with various cash flows coming on different timelines, it is always a good idea to draw the cash flows, then pick your focal date and move everything to the focal date, each cash flow individually to the focal date, and then try to compute the total accumulated value. That's all. Let's now prepare ourselves by solving the problems in assignment 1. These problems are very simple. You try your hand on them, you try to master these BA2 strokes, and then we will make you prepare for the next level, which is the nominal rates and force of interest. Force of interest is where the compounding happens continuously. Nominal interest is something like with the terms that banks or insurers or debitors or creditors use. So some they say 12% compounded monthly, they may say 12% capitalized monthly, or some other terms. So we will understand all these details. We will dissect the ad and the math behind it in the next week. See you in the next week. Thank you.